Imagine this. Late tonight, observatories around the world detect something strange at the edge of the solar system. At first, it seems like a mistake, a faint signal, a dark mass, a moving object with no visible glow and no familiar orbit. But as more telescopes turn toward it, the data becomes impossible to ignore. Something massive is drifting through the darkness between the stars, and it is heading into our cosmic neighborhood. It is not a comet. It is not an asteroid. It is not a planet that belongs here. It is a rogue planet, a world with no star, no sunrise, and no permanent home. A planet that may have spent millions or even billions of years drifting through interstellar space. And now, by pure cosmic chance, it may be entering our solar system. What would happen if a rogue planet entered our solar system tomorrow? Would we even see it coming? Could its gravity disturb the planets, unleash swarms of deadly comets, or somehow put Earth itself in danger? And if humanity had enough warning, could we do anything to survive it? Tonight, we are exploring one of the most chilling possibilities in astronomy. Not because it sounds like science fiction, but because rogue planets are real. Somewhere out there in the darkness, countless lonely worlds may be wandering through the Milky Way right now. Invisible, silent, and unpredictable. And one day, one of them could come close enough to change everything. To understand how serious that would be, we first need to understand what a rogue planet actually is. Most planets form around stars. They are born from giant disks of gas, dust, rock, and ice surrounding young suns. Over time, gravity pulls that material together, and planets settle into orbits that can remain stable for billions of years. But not every planet gets to keep its star. In the violent early years of a solar system, giant planets can tug on one another with enormous gravitational force. Some migrate inward, others get pushed outward. In the most chaotic cases, entire worlds can be flung out of their own systems and cast into the frozen darkness between the stars. These exiled worlds become rogue planets, forever traveling alone. And astronomers think they may be incredibly common. Some estimates suggest there could be billions of rogue planets in our galaxy, maybe even more than there are stars. That means the Milky Way may be filled with dark, wandering worlds that reflect almost no light and are nearly impossible to see unless they pass close to a star or give off enough heat to be detected in infrared. That is what makes them so unsettling. A rogue planet would not blaze across the sky like a comet. It would not shine like a star. If it were cold, dark, and far enough away, it could remain hidden for a very long time. Even a world larger than Earth might slip through space almost unnoticed, especially if it approached from the outer darkness beyond Neptune. If one entered our solar system tomorrow, we probably would not discover it because someone saw it with the naked eye. We would discover it through strange gravitational effects, unusual movement among distant icy objects, or the faint heat signature picked up by powerful telescopes. The first sign might be confusion. Astronomers could notice that bodies in the outer solar system were moving in unexpected ways. A handful of distant objects beyond Neptune might begin showing unusual orbital changes. Long-period comets could start falling inward from the farthest reaches of the solar system. A faint infrared source might appear where no known object should be. At first, scientists might suspect an error, a hidden dwarf planet, or some previously unknown object orbiting far from the sun. But then, the terrifying truth would emerge. This object is not orbiting the sun at all. It is passing through. That changes everything. If the rogue planet enters from the far outer edge of the solar system, the first region it would disturb is likely the Oort cloud, a vast shell of icy debris surrounding our solar system at enormous distances. Most of the time, those frozen objects remain untouched in deep darkness. But a massive intruder could disrupt them, sending some outward forever and pulling others inward toward the sun. Those inward-bound objects could become long-period comets, and some might eventually cross the paths of the inner planets. That means, even if the rogue planet never came anywhere near Earth, it could still create danger by stirring up a future wave of comet impacts. The next region at risk would be the Kuiper belt, the icy zone beyond Neptune that includes Pluto and countless frozen bodies. Here again, the rogue planet's gravity could create chaos. Stable orbits could be disturbed, collisions might increase. Some objects could be thrown deeper into the solar system, while others might be ejected into interstellar space. Then comes the question everyone would ask. Could it affect the major planets? The answer depends entirely on how close it gets and how massive it is. Space is incredibly vast. A rogue planet passing through the far outer solar system would not automatically mean disaster for Earth. If it remained well beyond Neptune, the immediate danger to our planet might be limited. But if the object were large enough or came deep enough into the solar system, the risks would rise fast. A rogue planet with the mass of Earth would be serious. A rogue planet with the mass of Neptune would be far worse. And a giant world with the mass of Jupiter would be a true gravitational menace. The planets in our solar system are not random objects floating independently. They form a delicate gravitational structure. The giant planets in particular help shape the stability of the whole system. Add another massive body moving through that arrangement, and you are introducing a new force into a machine that has run in relative order for billions of years. Even a small change in one planet's orbit can influence others over long periods of time. And then there is the nightmare scenario. What if the rogue planet came close to Earth? A direct collision would be almost unimaginably catastrophic, but even without impact, a close pass could still be devastating. Its gravity could alter Earth's orbit around the Sun, changing how much sunlight reaches our planet. A shift inward could warm the Earth over time. A shift outward could begin a long planetary freeze. The Moon's orbit could also be disturbed. Tides might change. Earth's tilt, the angle that gives us seasons, could become unstable. Over time, that could create violent climate changes far beyond anything in recorded human history. If the rogue planet passed extremely close, tidal forces might stress Earth's crust, possibly triggering major earthquakes and volcanic activity. Oceans could behave unpredictably. Satellites might be thrown out of stable paths. Global infrastructure could begin failing long before the object reached its closest point. And perhaps the most terrifying part is this. We would have to watch it happen. This would not be like an earthquake that strikes without warning. It could be a slow-moving cosmic crisis unfolding over months, years, or even decades, depending on its speed and trajectory. Imagine scientists announcing that a rogue planet has been detected and may make a dangerous pass within the next year. The world would change overnight. Governments would hold emergency briefings. Every major space agency would redirect its telescopes and computers toward tracking the object. News coverage would become non-stop. Social media would erupt with panic, rumors, fake predictions, and apocalyptic claims. Some people would prepare rationally, others would fall into chaos. And through all of it, the rogue planet would continue its silent approach. Could humanity stop it? Probably not. This is what makes a rogue planet so different from an asteroid. With a large asteroid, humanity may one day be able to nudge it off course if we detect it early enough. But a planet is an entirely different level of threat. The energy required to meaningfully change the path of an Earth-sized or Neptune-sized world is far beyond anything we can currently achieve. Nuclear weapons would not save us. Rockets would not save us. There is no realistic planetary shield waiting to be activated. Our greatest defense would be early detection and accurate prediction. If we saw the rogue planet far enough in advance, scientists could calculate its mass, path, and possible effects. That would help humanity prepare for the real dangers, incoming comets, climate disruption, orbital instability, or regional disasters triggered by gravitational effects. If the danger came mainly from comets, we might launch defense missions to intercept the most threatening ones. If the danger were long-term climate change, countries might build underground food systems, hardened shelters, and new energy infrastructure. Survival would depend less on stopping the rogue planet and more on adapting to what it causes. But there is another side to this story, one that is just as fascinating as it is frightening. Could a rogue planet carry life? At first, that sounds impossible. A planet without a star should be frozen, dark, and dead. But some scientists believe certain rogue planets could retain internal heat from radioactive decay, leftover energy from their formation, or thick atmospheres that trap warmth. If so, some of them might hide liquid water beneath layers of ice. That means a rogue planet might not just be a frozen rock. It could be an ocean world in darkness. Think about that. An alien planet drifting between the stars, frozen on the outside, but deep below the surface, a black ocean kept warm from within. No sunrise, no seasons, no sky filled with daylight, just endless night above, and the possibility of life below. If humanity ever encountered such a world, it would be one of the greatest scientific discoveries in history. Could we send probes to it, study its atmosphere, search for unusual chemistry or signs of life? In the middle of fear and uncertainty, a rogue planet would also offer an extraordinary opportunity, the chance to study a true interstellar world up close. That is what makes this scenario so powerful. A rogue planet would be both threat and discovery, terror and wonder, a danger to our civilization, and a clue to the hidden nature of the galaxy. Because the truth is, our solar system is not sealed off from the rest of the universe. We live in a moving galaxy filled with stars, black holes, gas clouds, asteroids, comets, and perhaps billions of wandering planets. The calm order we see in the night sky is real, but it is not permanent. Space is active. It shifts, it collides, it surprises us. And the idea of a rogue planet entering our solar system is a reminder of something easy to forget. Earth is not protected from the larger universe. We are passengers on a small world orbiting an ordinary star, vulnerable to forces so vast they are hard to imagine.
And yet, we also have something extraordinary. We can observe, we can calculate, we can understand. We can build telescopes that see heat in deep darkness. We can track invisible objects through their gravitational effects. We can take a terrifying possibility and turn it into a scientific question.
That does not make us invincible, but it does make us remarkable. If a rogue planet entered our solar system tomorrow, humanity's first response would be fear, but our second response would be knowledge. We would study it, measure it, predict it, and do everything possible to prepare. Maybe one day, our telescopes really will find one. A dark world moving slowly against the stars. A silent giant from interstellar space. And when that day comes, everything we know about planets, solar systems, and our place in the galaxy may change forever. Until then, rogue planets remain out there in the darkness, unseen, cold, and wandering. And that is what makes the universe so incredible. It is not just bigger than we imagine. It is stranger, more dangerous, and more mysterious than we may ever fully understand. Somewhere beyond the light of our sun, there may be worlds with no dawn, no home, and no name, drifting through endless night. And one of them could someday cross our path. If that happened, it would test our science, our technology, and our ability to stay calm in the face of cosmic uncertainty. But it would also remind us that we are part of a living universe, not a quiet museum of stars, but a restless ocean of motion, where anything is possible. So the next time you look up at the night sky, remember this: not everything out there shines. Some of the most powerful things in the universe move through darkness, hidden until the moment they arrive. And if a rogue planet ever enters our solar system, it will not just be a story about destruction. It will be a story about discovery, survival, and the fragile world we call home. If you enjoyed this journey into the unknown, subscribe to Infinite Science, because there is always more to explore. From black holes to alien worlds, dying stars to the edge of time itself, the universe is full of questions that challenge everything we think we know. And here, we keep asking them, because somewhere out in the darkness, the next impossible thing may already be on its way.